Hello, welcome to PhyzQuest. So this is the solution video for CSIR NET December 2019 Part A question number 19. So the question number 19 is an ice cube of volume 10 centimeter cube is floating over a glass of water of 10 centimeter square cross section area and 10 centimeter height. The level of the water is exactly at the brim of the glass. Now given that the density of the ice is 10% less than that of the water, what will be the situation when ice melts completely? So four options are given, that is after the ice melts whether the level of the water will increase or decrease or there will be no change. So let's discuss that. So there is an ice cube floating over a glass of water. Now let us see what are the information we have. First of all, the volume of the ice cube is 10 centimeter cube. Now it is already given that water is filled almost till the brim of the glass and the height of the glass is 10 centimeter. And the cross-sectional area of the glass is 10 centimeter square. So we need to find out what will be the change in the level of water after this ice completely melts. For that we need to find out the volume of the water displaced by the ice and the volume of the water formed after the ice melts. See, now according to the Archimedes principle, you know that whenever a body floats, whenever there is a body is put in a water, it displaces certain amount of water to occupy its space. So if the weight of the water is same as the weight of the displaced water is same as the weight of the body, then the body will float. So that is what the principle we need to use here. Now here, in order to, here the question is actually you have to check the level of the water. So for that, when we put the ice and it's floating, when ice is taking its place, some of the water will be displaced. Now that displaced amount of water we have to compare with the volume of the displaced amount of water we have to compare with the volume of the water formed after the ice melts. Then only by comparing these two things we will be able to comment on whether the level of the water will increase or decrease or it will not change. So now let us suppose it has a mass m. So now it will exert a force mg due to gravity. So that means it should go downwards, but it is floating. Now it is floating means the force due to the weight of the ice is balanced by the buoyant force by the water. So if mg is the weight of the ice and Fp is the buoyant force, now if it is floating, so that means in that scenario this mg is equal to Fp because the ice is floating. That means it is the weight of that ice is balanced by the buoyant force, means it's in an equilibrium position. Okay. Now what is the buoyant force? Now buoyant force, when it is calculated based on the water displaced by the ice. So if, let us suppose, the mass of the displaced water is md, that means the buoyant force will be md into g. Now we know that mass is equal to volume into density. So that means we can write this mass of the displaced water in terms of volume of the displaced water multiplied with density of water. That means Vd, which is the volume of the displaced water, into rho W, which is the density of water multiplied with G. So from this expression we can calculate the volume of the displaced water Vd. The expression of the volume of the displaced water Vd is equal to m by rho W, that is mass of the ice divided by the density of the water. This is the volume of the water which is displaced by the ice. Next is, we have to calculate after the ice melts. So after the ice melts, it forms water. So we have to find out what will be the volume of the water which is formed after the ice melts. So after the ice melts, let us say the volume of the water that the ice formed is Vw. So that means now Vw is equal to mass of the ice divided by the density of water. Because that is natural, because ice melts and water forms. So that means we have to calculate that, we have to use the mass of the ice divided by, since water is already formed by the ice, so we have to use the density of the water. Now if you look at the two expression, that is Vd, which is signifying the volume of the water displaced by the ice, and Vw, which is the volume of the water formed by the ice, both are, the expression are same. So that means the water which is displaced is the same as the water which is formed. So Vd is equal to Vw, and since both the expression are same, this signifies that the level of the water will remain the same. Now let us look at the options. Now if you look at the option D says there is no change in the level of water, which is the answer we have got. So option D is the correct answer. Thank you.